The converse of the Pythagorean theorem. In this video, I'll give you the definition of the converse. I'll tell you a little bit more information about it. We'll run through some examples, give you a reminder of some of your Pythagorean triples, discuss a common error, and then summarize. For our definition, we have, if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. This is just a rephrasing of the Pythagorean theorem. Basically what we're saying, instead of starting with triangle ABC is a right triangle, therefore a squared plus b squared equals c squared, we're going the other direction. We're saying if a squared plus b squared equals c squared, then the triangle is a right triangle. I would like you to note that sides are named with lowercase letters that are across from the angle with the same letter. More specifically, if you don't get them equal to each other, we can find out if we have an acute triangle or an obtuse triangle. It will be an acute triangle if c squared is smaller than the sum of the other squares, and it'll be obtuse if c squared is larger than the other two. Taking a look at our first example, do the sides 6, 8, and 10 form a right triangle? If not, classify the side by its angles. I know to put 10 squared by itself because it's the larger side, so it's the only one that could be a hypotenuse. I'm putting a question mark next to my equal sign because I'm not sure yet. And it turns out that both sides balance, so it must be a right triangle. Do the sides 10, 12, and 14 form a right triangle? Well, they seem to follow the same pattern because they're all 2 apart. In fact, they're all 4 higher than the other ones. So let's see if these 3 make a right triangle. So we're going to take 10 squared, 12 squared, and see if it equals 14 squared. Well, 10 squared is 100, 12 squared is 144, and 14 squared is, I believe, 198. 196, sorry. So, 244 on one side, 196 on the other side. No, they are not congruent. Well, and if c squared is smaller, this must mean it's an acute triangle. Something that might help you with these problems working a little bit faster would be the Pythagorean triples. And one of the triples we just used was a multiple of the 3, 4, 5. That one gets used a lot. So not only do we have these Pythagorean triples, but we have all their multiples. So for example, if we took these numbers and multiplied them all by 2, the result would also be a Pythagorean triple. Pythagorean triples are integer solutions to the Pythagorean theorem. It means they're whole numbers, no decimals. The common error I see, going back to this slide, is mixing up the acute versus obtuse. So you should avoid this by focusing on c. If c is smaller, it's acute. If c squared is larger, then it's obtuse. And the way that I like to imagine it is by thinking, okay, if c squared is larger, I'm pushing the sides out, which pushes my angle out past 90 degrees. If c squared is smaller, I'm pulling in, and that's making my right angle smaller. To summarize, you should write down a quick version of the converse of the Pythagorean theorem, what other information you can find from using it, and see if you can think of a way that's going to help you remember that information. I gave you an example of how I remember it, but maybe you've thought of a different one.